Hey guys, this is Mr. C, and in this video I'm going to show you how to simplify square root expressions. So let's suppose you have the square root of 32. You need to break this down, and you always need to take the number and break it down into its individual primes. And so what I mean is 32 is even because it ends in a 2. There's many ways that you can break down 32 into two numbers that multiply to give 32. You could do 8 and 4, you could do 16 and 2. So I'm just going to do 16 and 2. So 2 and 16. Okay, so when I get to a prime here, then I go ahead and circle it so I know I'm done with that. I can't break down 2 anymore. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. Okay, so now I have 1, 2, 3, 4, 5 2's. Well, the square root of a number has an index there that's a 2. It's never shown if it's a square root, but we just assume that it's a 2 right there. And so what that means is, for a square root, 2 of these primes down here will be one of them on the outside of the square root when you take it out. And so, for instance, these two 2's will make a 2 when it comes out. These 2 will make another 2, but that 2 right there, it stays. There's not a pair with it. So that 2 stays underneath the square root. When you get done taking all these pairs out you can and multiplying them together, 2 times 2 is 4. And I have 4 times the square root of 2. So how do I know I'm right? Well, one thing you can do is you can take a calculator and you can take 32 and take the square root of it, and you get 5.65, 685, blah, 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 it keeps on going. If you take this number, 2 square root times 4, just make sure you get the same exact decimal, and since we do get the same decimal both times, then we know we're right. So that's one way to check to see if your answer is correct. All right, let's try another one. So this time we have the square root of 45. Okay, let's just get rid of that. Okay, square root of 45. A couple ways we can do that. Probably the easiest way would be 5 times 9. 9 is 3 times 3. We call this a factor tree, by the way. And after 2 steps, we get down to all of the primes that make 45. 3 times 3 times 5. Cool little thing here is the fundamental theorem of arithmetic says that when you break down an integer into its prime factorization, no matter which way you make the factor tree, every single time, if you did it right, you'll get the same factors, but they'll just be possibly in a different order. And again, that's the fundamental theorem of arithmetic, which I didn't learn until I got to college and took number theory. So having a little knowledge of that kind of helps. Wish I had been taught that, but that's okay. So here we have a pair of 3's. So the 3 comes out on the outside, but that 5 is left inside. So root 45 is equivalent to 3 root 5. There are lots of times when you're going to have to do this, especially when you're solving quadratics and you have irrational solutions and you have to simplify things. You can't just leave it like this. You have to try to simplify it completely. So you just have to get used to doing things like this, along with the Pythagorean theorem and some other different things you have to do in trigonometry. It does really help if you can simplify these square roots into something that's a little more simplified, so you can possibly simplify it later on down the road. We'll talk about that in some other videos coming up. All right, so let's try this one. Okay, this time we have the square root of 48. So I'm going to choose, I could choose 2 and 24. I'm going to choose 6 times 8, just to kind of shake it up. Now, both of those numbers are composite, so I can break each of these down. 2 and 3. 8 is 4 and 2. Could you write the 2 there and the 4 there? Of course. You'll just get your factors again in a different order. And the fundamental theorem of arithmetic says that we're going to get the same primes at the end anyway, so it doesn't really matter how you write these in what order. And so we have 2, 2, 2, 2, and 3. 2 times 2 is 4, times 2 is 8, times 2 is 16, 16 times 3 is 48. I know I'm correct. All right, so I got a pair of 2s. I've got another pair of 2s. And I have this single 3 right there that's going to stay under the square root. So 2 times 2 is 4. Just keep the root 3 there, and that's it. If you ever want to check, if the 4 was back underneath the square root, it'd be a 16 under here, because to put it back under the square root, you have to take the square of it. 16 times 3 is 48, and I get back what I started with. So the more advanced you get in your knowledge of this, the quicker it is to check and just make sure quickly that you know you're correct. All right, let's try our next one. And these are all, by the way, very common ones that I've seen many, many, many times. 72. Okay, let's break this down. Let's first go by 2 this time. Okay, 2 times what is 72? Well, some of you guys might need a calculator. So if you do 72 divided by 2, and it's okay to use a calculator, you get 36. So the 36 now, lots of different things you can do with that. 9 and 4, 6 and 6, right? 2 and 18. I'm just going to do 6 times 6. Now, I could break the 6's down further, couldn't I? I could break the 6's down into 2 and 3 and 2 and 3. But if I look at these two 6's, all I need is really a pair for it to come out as one of them on the outside. And so I could treat these, since I have a pair of them, like they are primes. And so I'm circling them even though they're not primes, but they do make a pair. This could make my life a little easier. The 2 6's come out, the 2 stays in, and now I've simplified the square root of 72 a little bit easier because I've saved myself a step. So after you've done many of these, you'll be able to look back and you'll be able to do these little tricks to just kind of make your life just a little bit easier. All right, let's try the next one. Okay, so now we got 108. Okay, so 108, the numbers are going to start getting bigger. If they're going to get bigger, let's just go ahead and divide by 2. Okay, 2 times what is 108? It's probably going to be 54, right? Because 54 times 2 is 108, so 54. Okay, let's break that down. It's even. 2 times, okay, what would that be? 27? 27, okay. 27, you can do 9 times 3, but also if you know your cubes, 27 is 3 times 3 times 3. Here I can save myself a step by knowing that little piece of information, and I can draw 3 little arrows off that one, or branches, and make 3 3s off of that. Okay, so now I've got a pair of 3s, I have a pair of 2s, and I have that 3 still left. Well, 3 times 2 is 6. Okay, so now if I take the 6 and I put it back under there, right, then that would be a 36 under there. And a 36 times 3 is 108. And so 6 root 3 is going to be equivalent to the square root of 108. And you can check your decimals to see if you're correct on that, but it should be correct. All right, let's try 150. After you've done a few of these and you get used to these numbers, then you can try different things. This one, you can try 15 times 10. The 10 is a 2 and a 5. The 15 is a 3 and a 5. So this time I have a pair of 5s. But now I have 2 numbers that don't have pairs. So what happens now is I take both of those, I'd like to call it like the garbage, I got to clean up the garbage here, and I multiply them back together, 3 times 2, which is 6, and that's what's going to go underneath the square root right there. So let's check this one real quick just to see if we're on the right track. So here's 150 square root. Okay, 12.247 keeps on going, it's irrational. Okay, let's do root 6 times 5 equals, and we see we get the same number, 12.247. So 150 square root, 12.247, just to check one more time. All right, so it looks good. All right, let's try this time, root 180. Okay, square root of 180. This time, let's do 10 and 18. Okay, 10 is 2 and 5. 18 is 9 times 2. And 9 breaks down further into 3 and 3. All right, so I've got a couple pairs here. Got a pair of 3s. Got a pair of 2s. And that 5 right there is just going to have to sit there, back under the square root. And so this one is 6 root 5 for that one. All right, let's check our next one. Square root of 128. Okay, this one we could do 2 and 64. Okay, now 64 is cool because that's a perfect square. That's going to be 8 times 8. And again, we can save ourselves some time and we can treat this like a pair of 8s. So that pair of 8s gets used up, root 2 sitting there, and you're done. And you didn't have to fool with these 8s and keep it going and going and going. So that one actually worked out pretty easily, 8 root 2. Okay, 192. Okay, so this time, let's divide by 2. So 192 divided by 2 is going to be 96. Again, it's even. 96 is going to be 2 times 48. 48 is 2 times 24. 24 is 2 times 12. Uh-oh, now I'm running out of room here, aren't I? 12 is going to be, let's go ahead and do like this. 12 is 2 times 6. And 6 is 2 times 3. Now that's another reason why I'm circling all of these, because if I do run out of room, I can kind of branch around like that and keep it going without kind of messing up my flow there. So I've got a pair of 2s. I've got another pair of 2s. Another pair of 2s. And a single 3 left. Okay, so I have 2 times 2 times 2, which is 8 root 3. Now, if the 8 goes back in, that's 64, right? And 64 times 3 is 192. So I know that that expression and this expression are equivalent, 8 root 3. Okay, let's try another one. 242. Okay, so 242. Sooner or later, these numbers are going to get kind of odd, get kind of weird. They're going to be big, and we're just going to have to just divide them and see what happens here. And so there's nothing wrong with using a calculator. 242 divided by 2 equals 121. I don't want you guys to think that there is anything wrong with using a calculator. There's really not. 121, I know that's 11 times 11. And those are both prime. So this time, the 11s come out as a single 11 on the outside, but the 2 stays inside. So 11 root 2 for 242. Now what happens if I add one number to that and I make it 243? Is that going to change things? Well, let's take a look. 243. This is where it helps sometimes to know your properties of numbers and how to tell, or actually it's your divisibility rules. But 243, if you add up all these digits, 4, 5, 6, 7, 8, 9, since the sum of all the digits is a multiple of 9, 9 goes into it, and 3 goes into it also. So I might start with the bigger of those two, 9. Okay, so what's 243 divided by 9? And that turns out to be 27. Okay, now some of you might have already seen 243 a bunch of times. So 9 is 3 times 3. And we've already talked about 27 as being 3 3s because it's a perfect cube. And so what happens is we get a bunch of 3s. So here's a pair of 3s. Here's a pair of 3s. And you got that single 3 still left. And so your final answer is going to be 9 root 3. Anytime, if you don't believe me, or if you question your results, if they just look weird, you can check it on a calculator. That's no problem. Check your decimals. All right, 288. Okay. So 288. First of all, that one is definitely even. And also the last two digits, 88, are divisible by 4. So that's something interesting too if you know your divisibility rules. But let's stick with 2. 2 is a nice, easy, safe way to go. So 288 divided by 2 equals 144. Now, if you know your perfect squares, then you know that 144 is actually 12 times 12. And that just makes life easier. So I can just go with 12 and 12, even though they're not prime. It's a pair. The two 12s come out. There's a single one on the outside. The 2 still is left on the inside, and it's 12 root 2. Done. Okay, 324. Try that one. Okay, so 324. Let's go by 2 again, because that's the safe way to go. So we got 324 divided by 2, and that's 162. Again, even. Let's try it again. Nothing wrong with that. 81. And now I've hit a perfect square. 81 is 9 times 9. I can stop there, circle them, and now I'm on my way. 9's come out as a single 9. The 2's come out. And here's the question. If everything came out, what's left? And believe it or not, most students will tell me 0 is left. But if 0 is truly left, then what's going to happen is your answer is going to be 0 because you're going to get the square root of 0 there. And so if you say what's left and the answer is 0, here's what you're really telling somebody. You're telling somebody that if 0 is left, you're multiplying it by the square root of 0, which is going to make this whole entire expression 0. That can't be correct. So that can't be right. So what is left? It's actually a 1. A 1 goes into every number. Every number is divisible by 1. So you can actually have 9 times 2 and then a root 1 right there. But a root 1 is just 1. It goes away with multiplication. We don't even need it. So why even bother? We'll just write 9 times 2 is 18. So what happens is 324, and let's just check that real quick. 324 square root turns out to be 18 because it's a perfect square to begin with. Now, people aren't going to remember their perfect squares probably past maybe 144 or maybe a few others, 169, some of those, but at 225. But it's okay because you can just use this procedure here, this mechanism, and you can get the square root no problem, even if you don't have a calculator really. So that one's done. All right. So let's get into some bigger numbers because that's usually what happens in math. We have to make things more difficult. So 468. So let's break this one down. Okay, so let's divide by 2. So 468 divided by 2 equals 234. Okay, that's even. Let's divide by 2 again. Divide by 2 equals 117. 117, it looks like you may have hit a stopping point. Some people might say, well, that's a prime number. Well, I don't think so, because 7 plus 1 plus 1 is 9, which means that 9 goes into it. So I'm going to divide it by 9. So divided by 9 equals 13. Now 13 is prime, so I'm definitely going to circle that. The 9 is 3 times 3. All right, so now it's completely factored into its primes. So here's what we got. A pair of 3s, a pair of 2s, and a 13. For a total of 6 root 13. All right. 693. Okay, so what can we do here for this one? Let's add them all up and see what we get. 9 and 6 is 15, plus another 3 is 18, isn't it? So we know that 9 goes into it. Also 3 goes into it. But I always like to take the bigger one just to get rid of it. Let's take 9. So 693 divided by 9 equals 77. Nice. Okay, the 9 is going to break down into a 3 and another 3. The 77 is 7 times 11. Okay, so we have a pair of 3s. Get rid of that. This guy right there, neither of those have a pair, so they just go back under the square root, the 77 that it came from, and then there you go. That's as far as you can get, 3 root 77. All right, 828. Let's try that one. Okay, so let's go by 2 again. So we got 828 divided by 2, that's 414. Okay, let's divide it by 2 again because it's even. 207. Okay, so now I've gotten to a number that if I add the digits up, it's again a multiple of 9. And so I can divide this one by 9. See how handy this is? To know that. Okay, so 207 divided by 9 is 23. So from experience, I know that 23 is prime. That's not going anywhere. 9 goes down into 3 and 3. All right, so let's see what we got here. Equals 3 times 2 times root 23. And so that's going to give me 6 root 23. And that's it. That's as far as I can go. All right. Let's try next one. 972. All right, so now we change markers here. Okay, so we got 972. So here we go. Let's divide it by 2. Okay, 972 divided by 2 equals 486. Okay, again, 243. Now, didn't we see 243 before? What was 243 before? That was, I believe, if we don't remember, that was divisible by 9. If memory serves me right, it was a bunch of 3s, right? So let's try that one. Divided by 9 and we get 27. Yep, same as we did before. Okay, so the 9 gives me a couple 3s. The 27 gives me 3 more. It's a perfect cube. All right, so let's see what we got. A pair of 3s. Another pair of 3s. A pair of 2s. And 1 3 still left. 3 times 3 is 9, times 2 is 18. So we have 18 root 3. Should do it for that one. That wasn't too bad, even though the numbers are getting kind of big. 1024. I've got an idea what's going to happen here. I'm thinking we're going to get a bunch of 2s. Let's find out. Okay, so let me switch markers one more time. Get one that's gonna give me a little finer point here because I feel like I'm gonna have a bunch of primes. Okay, so 2. All right, 1024 divided by 2 equals 512. Okay, again, 2, it's even. 256. All right, 256. Do you know your perfect squares? What is the square root of 256? Boom, 16. That means that 256 is broken up into 16 times 16. Both of those can be broken down again and again and again, but since I have a pair, I'm going to exploit that, and I'm going to use that pair to factor. Because I'm not really needing to factor into all the primes, I just need to simplify the square root in any means necessary. So if I can do this, then I'm good to go. a pair of 16s, got a pair of 2s, nothing else but a square root of 1. And 16 times 2 is 32. Well, let's check it. 1024 square root 32. A lot of students will start to realize, hey, let me just go ahead, before I even get started, I don't know my perfect squares. I'm going to just go ahead and take this number right there, take the square root and see what happens. And sometimes you will get a perfect square right to begin with in the calculator, and you're pretty much done. A lot of times the higher math classes that you go to, the less frequent that's going to happen. But it happens a lot in Algebra 1 and in 8th grade math. All right, so let's see what else we got here. A couple more, 1125. And I've got to put this behind these papers so it doesn't bleed through. All right, so let's take this one, and since it ends in a 5, we're going to divide it by 5. So 1125 divided by 5 equals 225. Okay, again, I come to a number that I've seen before many, many times, 225, and I'm thinking maybe that's a perfect square. I could divide it by 5, but if I hit the square root button, 15 it is. Knowledge is power. I can take these two 15s and I can circle them just like they were primes because they're serving the same purpose. And I can now say 15 root 5 for my final answer, and it's done in like 2 steps. Easy. All right, and our last one, I can get rid of this, is 1344. Let's see what I've saved for last. All right, here we go. Let's divide it by 2. Might as well. Okay, so 1344 divided by 2 is 672. Okay, not a number I've seen a lot, so we're just going to divide it by 2 again. And I get 336. Okay, that one, interesting. It's 6, 7, 8, 9, 12. So that's divisible by 3 if you add them all up. It's also even. So since it's even and it's divisible by 3, it has to be divisible by 6. That's one of the rules that they teach you in 7th or 8th grade. So let's try 6 divided by 6 equals. And sure enough, if I try 6, it's 56 over here. But now I'm going to have to break the 6 down quickly into 2 and 3. The 56 is even. And so if we take 56 divided by 2, and that's 28. 28 is 7 times 4. And 4 is 2 times 2. All right, so now we've broken it down into all of its primes. Let's see what we got here. Be very careful when there's so many of them. That's why I circle them. So I have a pair of 2s. So there's a 2. I've got another pair of 2s. There it is. I've got another pair of 2s. Okay, what do I have left? A 7 and a 3. So that's what, 21? So times root 21. 2 times 2 times 2 is 8. Root 21. That one's worthy of checking real quick. So let's check that real quick just to make sure we didn't make any mistakes. So 1344 square root 36.66, and it just keeps going because it's irrational. All right, let's check our final answer here. Let's remember 36.66. So 21 square root times 8 equals same exact number. So we know we got it. All right, guys. So this is a nice little introduction into simplifying square roots. Hope it helps. Next, we're going to get into simplifying radicals in general, some square roots, cube roots, and so on. So remember to like and share and subscribe, and we will see you guys later. Bye.